For Calc 2 Week 5 video, we're going to be calculating work to pump the water out of a conical tank. So the problem is, calculate the work in joules needed to pump all the water 6 meters above an 8 meter high conical tank with a top radius of 10 meters. So we have to start with finding the volume of this slice, and then we're going to integrate all of the slices. So we're going to denote a slice with a subscript I. So we're going to be finding V of I. So we're looking at this slice here, and we need to find the volume. So we know that that's going to be the area times our change in y, or height. So area is pi r squared, and in this case our radius is this x of I. So we're going to have pi times x of I squared times our integrating dy with respect to this distance right here. So then we need xi in terms of y because we're integrating in terms of y. So we use similar triangles. We know that the radius, this triangle, is going to be similar to this triangle. And we can use that to find it in terms of y. So we have a radius of 10 and over a height of 8 is equal to our x sub I radius over our y sub I height. And we get that x sub I is equal to 5/4 y sub I. So we're going to put that in for this x sub I. So after volume, we need to find the force using what we already have. So the force of a slice is this V sub I. So pi, plug in the x sub I, 5/4 y sub I squared. And then we need to account for the density of the water, which is 1,000 kilograms per meter cubed. So multiply by 1,000. And we need to account for gravity, 9.81. And then we still have our dy. So that's the force, and from force we get the work on a slice. So the work on one slice is going to be this force times the distance that we're pumping out. So at the top we have a point here that's 6 meters above. So at the top you're going to be at 6 meters plus your 8 meters height of the tank. That's going to be 14. And then depending on where you are, here we're going to be at 14 minus some y distance. So we're going to say 14 minus y. So then all we do is we integrate from just the height of our cone, so 0 to 8, this work on the slice. And if you do that, you should be getting $20,928,000 joules.